Hey, Voiceflow builders. Imagine an AI-powered air traffic control system experiencing a sudden API outage. Seconds matter. Lives are on the line. Are you serious about building AI for real-world mission-critical projects? What happens when the very system orchestrating your AI encounters API failures, service disruptions, or model hiccups? For truly reliable AI, we need the orchestration itself to be bulletproof. And that's exactly what we are building today. So this function will be relevant for mission critical applications such as emergency response systems, financial trading platforms, as well as critical infrastructure management. In this video, we are introducing the Orchestrator function, your essential tool for building robust reasoning directly into your Voiceflow project, especially for those mission-critical deployments. This single powerful function is the orchestrator. It's designed to prevent its own failure while intelligently switching between powerful reasoning models such as OpenAI's O1 and O3 Mini and Google's Gemini 2.0 Flash Thinking. It's all about ensuring unwavering, reliable reasoning even with real-world API issues. We will explore Gemini's code execution, and it's all done right here in Voiceflow. Let's get started. OpenAI can sometimes have an error in processing your request, or sometimes you may mistakenly provide OpenAI with an invalid key, or there could be other things that are beyond your control, such as a system failure. We can also see that Anthropic has similar issues. There can be API errors. We can also see that Gemini also has similar issues. Also, DeepSeek has error codes, meaning that DeepSeek can fail. So looking at the service status at OpenAI, you can see that there have been some major outages at various parts. We have Anthropic also having some errors. We can also see that Gemini also has some errors. You can also see that DeepSeek also has some major outages as well as partial outages. Let's quickly understand why reasoning models are crucial. They are advanced AI for complex tasks needing deep thought, problem solving, just like multi-step reasoning and handling ambiguity, which we know that traditional models often struggle with. And this is essential for mission-critical applications. That's where the power of robust reasoning, driven by advanced AI models, becomes absolutely essential. Models like OpenAI's O1 and O3 Mini and Gemini 2.0 Flash Thinking provide this. Our orchestrator function leverages three top models. We have the flagship O1 model, which is normally the gold standard for complex tasks, as well as is able to control its reasoning effort. And we can have different types of response, which could be a text or JSON output or JSON schema. So we also have the O3 Mini, which is the efficiency powerhouse and has exceptional STEM reasoning, as well as lower cost and latency. And this model supports function calling and can do structured output as well as reasoning effort like the O1 model. Next is the Google Gemini 2.0 Flash Thinking Experimental, and this model is known for its speed as well as insight leader. It excels in rapid explainable reasoning in math and science, and it has a massive 1 million token context window, and it can also do to use as well as some native multimodal capabilities. This Gemini 2.0 Flash Thinking has been known to top the leaderboard for a number of weeks now. So you may want to ask the question, why just these three? DeepSeek R1 is incredible and I intended to include it, but I'm facing an insufficient balance issue. So I made an API call to DeepSeek R1 and I got this. DeepSeek has high demand restricting top-ups. This shows why fallback is crucial. Even top models face availability issues. APIs overload, accounts have problems, it happens. And this is the more reason why we need this function. Before we get into the function, let's talk about the design principle. The orchestrator function is inspired by the Orchestrator-Workers pattern, a powerful concept in building robust AI agents. You can find more in Anthropic's Building Effective Agents. In this pattern, a central orchestrator intelligently delegates tasks to different workers. Think of it like a project manager. The project manager picks the best workers and sends the tasks to those workers. Critically, in this pattern, The orchestrator is the single most important component. If the orchestrator fails, the entire workflow breaks down, regardless of how good the individual workers are. Our Voiceflow function doesn't literally manage worker processes. The orchestrator function itself is the orchestrator. It internally manages the reasoning models, that is O1, O3 Mini, and Gemini 2.0 Flash Thinking. And the function's own code handles selection and fallback. It's an implementation of the pattern for Voiceflow. This gives us resilience, flexibility, and intelligent management, all within one function. And most importantly, the function is designed to be robust against the very failures that could cripple a traditional orchestrator. So how does the orchestrator function achieve this robust reasoning? And how does it prevent its own failure? The key is in its internal design. The function is the orchestrator. It's a single self-contained unit that intelligently tries different reasoning models in a sequence. This sequence, combined with robust internal error handling, is what makes it so reliable. Function's primary goal is not just to get a response, but to ensure that the reasoning process itself doesn't fail. Even if individual models or their APIs have issues, you are able to control the model order. So the core robustness is the internal error handling. Let's take a look at the technical details. So we can see here that we have the system prompt, and in the system prompt is where you put your instructions. We can also put in the user input, OpenAI key, Gemini key here, as well as you can specify the model order here, and then these are the models that we are using. We can also enable code execution by putting this true or false, and code execution is relevant to Gemini 2.0 Flash Thinking. We can also see the LLM success output, or if there are any errors, the details we provided here. We can also see the various outputs that are coming from the model here as well. We can see here that the model that succeeded in providing the response is stored in this variable. So you need to create all these variables in your Voiceflow project. There is also information about token usage and the amount of tokens that was used in the reasoning. We also have other information for Gemini, and in case if the model used code execution, it will provide the code here, and also the language, which is most often the Python language, and then the output and the status of that code generation. We can also see here that if enable code is true, then we are going to use code execution. So now let's talk about code execution. With code execution, Gemini can write Python, run it, and use the output for reasoning, like a built-in calculator. For example, if you ask Gemini to calculate the area of a circle with a radius of 5, it could generate and execute Python code to do that precise calculation, rather than just relying on its pre-trained knowledge. And this is very great for math as well as analyzing data. And it has many interesting built-in libraries. When the code execution is true and the user enters a question, the Gemini model first determines whether this user question requires a Python script in order to help address it. If it doesn't, then it provides the answer. However, if the Gemini model determines that it needs to use a Python script, then it generates a code and then executes that code. So in terms of costing, the costing takes into consideration the prompt that was used, or the user question, and the system prompt, the message prompt, and then as well as the code here that was generated, and then the result of the code. And then it provides all that output as well. So now let's see the robust reasoning, errors and code execution. So here is the flow, and in the flow, here is the welcome message, here is the user question, here is the prompt step, and this prompt step has just a very simple prompt, and then here is the orchestrator for a robust response. So what we are going to do is that we are going to specify an order for the model. So what we are going to do is that we have the model orders 1, 2, 3, which is the O1 first, the O3 mini, and then the Gemini 2.0 Flash Thinking. So what we are going to do is that we are going to test these models to see the outcomes from these models. So the first one is the O1 model. And remember, we still have the O1 model set at high for the reasoning effort. And here we can see the response that is being generated by the O1 model. We can also see the number of tokens that are being used for this particular request. Let's try the O3 model. So we can see here that this is the O3 mini model, and is able to generate a very good response when the user asks the question. I like how Voiceflow streams the response. The next is that we're going to use the Gemini 2.0 Flash thinking, and then we are going to use it without code execution. So we can see here that the Gemini model is being used without code execution because we put it on false. We expect that code execution would be undefined because we actually have made it false. So the next is that we are going to make code execution true. Because this particular question obviously doesn't require code, the model should intelligently determine that and not use code. So we can see the Gemini model being used here is using code execution. However, it's not going to provide any response here because the question that we put doesn't require a code to answer that question. Okay, this is great. So let's do some quick math. So we have here what we call the Fibonacci sequence, which was developed by an Italian mathematician. The Fibonacci sequence is this fascinating series where each number is the sum of the two before it. So for instance, when you have 3 here, 3 is the sum of these two. This 8 is the sum of these two numbers here and follows in that sequence. And this pops up everywhere in nature, like the spirals of the galaxy. So what we have here is that we're going to test the reasoning capabilities of these models. We are going to use this Excel sheet to check the scores of the various models. So we're going to test the first model as O1. Now let's enter the question about Fibonacci. So the seventh Fibonacci number is 8. So the O1 model got it wrong. And this is O1 model on reasoning effort high. So we can see here that the seventh number, 1, 2, 3, 4, 5, 6, 7, is actually 8, not 13. So we are going to give the O1 high model, we're going to give it 0. The next is to test the O3 mini. So now let's see what the O3 mini would do. So the O3 mini also got it wrong. We're going to give it 0. And the O3 mini is using the high reasoning effort. So we are giving it the best of the chance to get this correct. We're going to use Gemini without code execution. So we are using the Gemini without the code execution. And we can see that the Gemini model without code execution also got it wrong. I think our last hope is Gemini 2.0 Flash Thinking with code execution. So let's enable the superpower for Gemini. Let's publish it and all fingers crossed. So we are using the Gemini model with code execution. So code execution is using a Python script behind the API to determine the answer. And voila, the only model that got this correct is the Gemini model. Well done, Gemini, with code execution. So let's give it a point here, 1. So now it's leading. The next question that we have is what is the sum of the first 50 prime numbers? So since we already have code enabled, let's start from the bottom. So this is going to use the Gemini 2.0 code execution. And we can see it got it correct. And then now it's trying to generate the code that was used. So Gemini is leading. The next one is the 2.0 no code execution. So it got it wrong. And that's because it's using no code execution. So we give it 0. The next is to try the O3 mini model. this is quite an interesting comparison, especially for the Fibonacci question. So we are using the O3 mini, and the O3 mini is on high, so we expect a bit more from it. And voila, it got it correct. Now let's try the O1. And it got it correct. 1 for that. So the next question that we have is this. So since we have the O1 model, let's start with O1. And it got it correct. So well done to the model O3 mini. It also got it correct, 11 out of 3. The next is to try the Gemini model without code execution. This is Gemini without code execution. And it got it correct. Well done, Gemini. So now let's try to enforce code execution. And it seems to have gotten it correct. I've noticed that the Gemini model really provides a lot of output. So this is very good. So let's give the Gemini model 1 to generate 5 random numbers between 10 and 50, then calculate the average and median. And since you already have Gemini with code execution, let's just use it. So the answer to this really depends on the random numbers that will be generated. 12 and then 11. What would the answer be? You can see that the answer is 24.8, and then the median is that. And then this is the Python script that was used to develop. And then these are the results from the Python execution. So let's give it. The next is to try without code execution. So let's test these random numbers. And it got it correct for that as well. O3 mini on high reasoning effort. We are testing the O3 mini. So we can see that I got the answers correct. So let's give it 1 as well. The next is the O1 with high reasoning effort. Check the responses. We can see that it also got it correct. So we have the last question, which would confirm the intelligence of these models. The last question is, so you want to do 3 things: the average age of the people. We also want to find a person living in London, which is Bob, and then we want to sort by age in ascending order. So since we already have the O1 model, let's just use that. Okay, so we have the average age 30, Bob, and then we have Bob, David, Alice, Emily, and Carol. So it got it correct. Now let's test the O3 mini model. So now let's use the O3 mini model. So it seems to also have gotten it correct. Okay, that's correct. So let's give that one as well. Hopefully the Gemini with code execution should get it correct, otherwise it will tie with the others. So let's go use the Gemini model without code execution. Without code execution. And it seemed to have gotten it correct. That's good. So we give it 1, the code execution. The last model, that's Gemini with code execution. So we're expecting that it to be able to generate some code here and then use it. And it's already gotten it correct, 30 bulb. So let's look at how the code looks like. So it just uses a Python script to answer the question and then it provides the answer. So I think we all know the winner for today. Yeah. Great. So the next that we want to do is we want to try to simulate an API error so that we would see how it falls back to the Gemini. So let's just put the Gemini at the last. Let's keep this at true because we're going to ask it a very trivial question which doesn't require code. So it should be able to determine that this does not require code and there's no need to generate it. So we're expecting that O1 will pick it up, but we're going to actually make a mistake or delete some characters in the API key. So let's make an error in the API key. Let's change this to a K and save it. So that is the wrong API key. So we're expecting that it should be able to go to the next model, which is Gemini, even though Gemini is number 3. And remember, we've put in Gemini on code execution, but the question we're going to ask it is a very trivial question, which is what AI solutions? And it doesn't need code to do that. And you see it did not need to use the code. This is very good. The fallback system is working. So some of the use cases for this particular function is providing 24/7 customer support. So we all know that customers need answers anytime and downtime is lost sales. So this orchestrator functions ensures the availability 24/7 as well as providing very strong reasoning to understand the various nuances of customers. You can use this in banks to evaluate loans, to analyze data, assess the risk, and also make recommendations in real time. And we all know that in banking, errors is equal to losses. So this orchestrator function guarantees reliability and also reasoning is very vital in this sector. The next is the emergency response dispatch. So in this use case, we have first respondent agents. So you could have some triage calls and you would want to be able to understand various situations and dispatch resources as well as give instructions under pressure. So in such a scenario, failure is unthinkable. So the orchestrator function or this engine provides the uptime as well as the robust reasoning. So a tip that I would like to give is that first, for mission critical applications, you should first determine which model is best suited for that task. The next is that you may want to experiment with the modelOrder in order to prioritize speed or depth. You may also want to look into cost management by tracking the token usages, even for mission critical project, and try to optimize it. Also, you may want to thoroughly test as well as simulate failures and high loads. And these high loads could be trying to test the model during times that you know that the service providers are experiencing problems or issues and try to see how your model handles all those system overloads and API errors. We also have production. So never hard code API keys. Use Voiceflow Secret Manager. It's very secure. And then the next is also actively monitor the function in production. You have to track the success and the error rate, as well as the models that are used, and set up different alerts. Also, try to troubleshoot. Check your API keys, your model order, and check the Voiceflow logs, as well as you can ask below. So that's the orchestrator function. This template containing the function is in the description below. Check it out at our Voiceflow expert page and start building. Let's get started. So experiment, test, and share in the comment the mission critical project you're building, as well as like and subscribe. Thank you very much, and go build robust reasoning.